Hey everyone! If you've ever asked yourself, how do I build a custom mechanical keyboard? By the end of this video, you'll know exactly what tools you need, how to prep your parts, and how to build your board so it sounds and feels amazing. Before we start assembling anything, let's lay out all the parts that make up a custom mechanical keyboard. Seeing everything at once helps you understand how each component works together and makes the build feel way less intimidating. At the core, you have the PCB, which stands for printed circuit board, which essentially registers every key press and determines whether your board is hot swap or soldered. In this example here, these are hot swap sockets that allows you to put your switches into these without soldering them into the board, and allows for easy switching of switches. You'll be then pairing this with a plate which sits on top of the PCB and holds your switches in place. This can be aluminum, polycarbonate, FR4, polypropylene, or other materials, each of which affects the sound and the feel. In this example here, you have your FR4 plate, which is a middle ground balance of typing feel, flex, and sound depth. Interestingly enough, FR4 is the same material that's being used to make PCBs. Next up, we've got switches. They are the heart of the keyboard, controlling how each key feels and sounds. Make sure you check out our store at www.LumeKeebs.com. We carry a very wide range of switches, mechanical keyboards, as well as pre-built boards. Next up, we've got stabilizers. These are the pieces that support the larger keys, and it's important to prevent wobble and rattles. Over here, you see an example for the space bar, and these are for the medium-sized keys, such as enter or shifts and so forth. Next up, you've got an array of foams and films right here. You've got your PE foam right here and a PET sheet. These two help shape the sound profile of your board, where your first layer is your PET that goes onto your PCB, followed by your PE foam right here. It goes on top. Make sure you line up the holes correctly because your switches are going to plug through this. And on top of that, foam that goes between your PCB and your plate. That is the standard sandwich that we have here. This is all going to be held together once you put your switches in, and that's what's going to hold all this together and make it sound really good. The other pieces of foam is for the case itself. This piece right here, it's got cutouts that matches these little shapes in the base of your board. So that is basically lining the bottom of the case. This serves to reduce ping within the case and resonances. With a metallic case like this, there's going to be some resonances with different frequencies, and what this does is it helps absorb some of that. This is the piece of foam that then goes on top of the base case foam, but goes underneath the PCB, right? Serving a similar purpose to reduce pings and to deepen the sound profile a little bit. Don't worry, as we build the board, we'll show you how this all comes together. Different boards are going to have slightly different designs, and some boards are going to be designed with more foam in mind. For some other builds, you can also go with other keyboard designs, or you can also build this board without the foam. Next up, you've got your gaskets. These are typically made of silicone. It holds your PCB and mounts it onto the case. The reason why we use silicone is to create a soft connection as well as reduce any harsh sounds that passes through from the PCB to the case. We'll show you how to use them as we build the board itself. Next up, you've got your ribbon cables. These are going to be board dependent. Some boards use ribbon cables, some use pogo pins these days. Next up, we've got your USB dongle. This plugs into your computer and serves as your receiver for 2.4 gigahertz wireless. Most boards these days are tri-mode, so you can do wired, Bluetooth, or 2.4 gigahertz. 2.4 gigahertz serves to reduce latency, so if you game and you want a wireless connection, 2.4 gigahertz is one you want to go for. Last up, you've got your cables, switch pullers, keycap pullers, and a screwdriver. That rounds out what's in the kit. Before you start any build, the first step that you want to take is actually testing your PCB. Essentially, you're making sure that there are no faults within the PCB before you actually start your build. And the reason we want to do this is most manufacturers provide a lot better support and warranties on your PCBs if they have not been used. First two steps that you want to take is one, taking a look at the sockets within the PCB and doing a visual inspection. You see the square hole right here. There should be two metallic leaves that's touching each other. Make sure that they are in place and they're not misshapen. Take a look through. it should be uniform across each of these sockets. If any of them look different and the shape seems off, contact your manufacturer or your retailer and they'll be able to sort you out. After that, you would also want to do a continuity test. Essentially what you're going to do is take a pair of tweezers and you're going to touch the sockets. Make sure you're only touching the contact point between the socket itself, right? So don't do this as an example, right? You're only going to touch the socket, point in the socket, and what that does is it simulates a key press. And so when you have this board plugged into the computer, you're going to be able to test each of these sockets individually to make sure that they're functioning electrically as it should. Next step is to prep the stabilizers. As we mentioned before, stabilizers serve to stabilize the larger keys in your keyboard, and these are very important to make sure they sound good when you're pressing these larger keys. One critical step here is to lube your stabilizers. You could technically do without it, but your board will not sound as good as if you lube them properly. We have another video that shows you how to lube them. Please make sure you subscribe to our channel so that you get the latest and greatest versions of the videos that we have. In this video, we are going to use a set that we have already lubed. At LumeKeebs.com, we do provide lubed switches and stabilizers as well. So if you want to get them professionally done, we are able to provide that. So check out our store if that's the direction that you want to go for. There are two primary types of stabilizers. These are called screw-in stabilizers. Essentially, you screw them into the PCB. They're also clip-on stabilizers as well. Screw-ins tend to provide better stability, but they do take longer to install. Clip-in stabilizers snap into the PCB or plate and are quick and easy to install, making them more beginner-friendly. But depending on the design and the tolerances, they could potentially move and rattle if not tuned well. If you have rattling on your larger keys, adding a tiny bit of lube with a syringe usually would help do the trick. Before you put in the stabilizers, make sure you put on your films on top of the PCB. Stabilizers that we have will go into these holes right here, the slightly larger ones. As you can see, there's a cutout in this PET film right here, but there is none on the PE foam apart from these little pre-cut, but not all the way cut pieces. So what we're gonna have to do is to poke these out. As you can see, the piece that I tore off matches this hole right here, which is where our stabilizer is going to go. Depending on your board, this might already be done, or it might be like this where you've got some pre-cut pieces that you need to poke out. We're just going to do this very carefully to make sure we don't tear the entire sheet, as it is quite fragile. These foams are designed for different versions of the PCBs that they have, and so depending on the PCB that you got, you might not need to tear off all of this. Each manufacturer typically has a few different PCB designs, and depending on PCB that you choose, the holes may not fully line up, and so they cut each of these sheets more than you need to. As in another example right here, there are no stabilizers here, so this is for a different layout, and so you're just going to take a look at where these big holes are, and those are the cutouts that you want to push through. In this case here, it's pre-cut for all of these, so you don't have to deal with it, but for the PE foam right here, that's what we're doing here, and we're lining this up here. And so next up is this piece right here. We're going to push that out. The large holes where the stabilizers go through is this one right here and the small one right here. So if you take a look at this sheet, you'll be able to see there are these cutouts to line up to this large hole and a small hole. It's always going to be a large and a small and a large and a small. So your stabilizers will go over here and here, here and here. Key here is just to go a little slow to make sure that you're poking out the right ones. Lastly, we have a few over here, so you can take a look. The ones that are vertical are the ones that you want, but we'll just do a quick double check against the holes on the PCB, and surely enough, vertical, 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 right? So those are 4 that you want to punch out. And voila! Now we are ready to put our stabilizers on. Depending on the stabilizer kit you have, you may have these little stickers. The purpose of these stickers is essentially to dampen the sound of the bottom out of your switches. So as your switches go down on these stabilized keys, these, if you tape them here, acts as a cushion so that the stabilizers, instead of hitting a PCB, they're hitting these soft pieces of tape. Line up to the hole. As with everything in a mechanical keyboard, these are a matter of preference. For demonstration, we are going to put all these on, just so you see what it's like. Now you've got these back on, we can start putting the stabilizers. The clippy side, right, you can see a little hook. That's what you want to put to the larger side of the hole. Once you hook them in, press down, and it should snap into place. You then have these little spacers, and it serves to help dampen any vibrations from being transferred to PCB as well. So let's do the first one here. First stabilizers are on, and they're on securely, which is great. And just keep moving forward. Excellent. We have the stabilizers on the board. Each of these are in the right directions. With that, we can now put on our foam. As you can see, there is a pre-cut area here, which we are just going to pull apart. To be able to give space, as you can see, it's kind of in the way. You want to then remove this piece. To remove this piece right here to give us a little bit more room to work with. Next part is when we start putting in the switches. Over here we've got the HMX Azure, which is one of our favorite switches here. The most important part is to make sure that all of your foams are aligned and you can easily see the holes at which you would be poking your switch legs through. Make sure to support the sockets. So if I'm putting this switch in, my left hand or right hand is basically pressed up here as I'm pushing the switch in, right? What that basically helps is to make sure that the socket is not shoved out of position and that you don't break the socket. As you can see over here, the switch is not fully hooked into the plate. Top part of the switch is hooked onto the plate, but the bottom part is not. You can see that part right here. And the reason for that is because we have a flex cut plate. What you can do is you can take a pair of tweezers. As you're holding the switch in, you can lift the bottom of the plate so that it locks into place. To lock it into the switch. The key here is, if you take a look over here, you see that the bottom is not locked into the plate. Over here, you can see that it is, right? Next up, we start filling it from the corners. We've got most of our switches in. The ones remaining are the tricky ones. So if you take a look over here, this socket's a little tricky in that there's two sets of holes, right? You have two sets of holes right here on the bottom, two sets on the top, where your legs of the switch would go, compared to the normal one where it's just one set of holes up top. One way you can confirm that is to flip it over, and as you can see, for a normal socket there's only one socket right here, whereas for some of these you've got two sets of socket for one switch. 1 and 2. These two are serving the same socket, and the reason for that is to allow for different layout. And so depending on the layout you choose, you are going to have to either pick to put the switch from one of two orientations, right? Normally your switch has your legs pointing up, but in this special case, flip the switch upside down and put it in that way. And so lastly, you put the space bar in, and we're done. Our switch is in. Next step is to disassemble your case. Depending on the board that you have, this step would be slightly different, but generally speaking, it usually involves you removing a couple screws. Keep in mind that these screws are typically quite small, so make sure you don't lose them. The screws are off, and you should be able to now take this apart. Top cover comes off, and that allows you to then put the PCB into the case itself. After which you'd put the case back on top, and it will lock it in place, right? So now that we've taken this apart, one is to get our foams back in and make sure they're well lined up. Here we do have some ribbon cables, so we're going to make sure that we get out of the way of the ribbon cable. It usually lines up pretty nicely. Depending on your kit, the alignment of this would be a little bit different, but the core concept remains the same. Perfectly aligns with the foam, right? Now that this is very nicely in, next part is to put the second sheet of foam on top. Once again, it should line up to some cutouts and shapes in the case. Make sure that it is in nicely. So you've got your PCB plate, bunch of foams and switches. What we want to do is to use these silicone spacers. So this is the silicone mount, and what you're going to do is you're going to slot them into these little cutouts on your PCBs to be able to act as a soft mount to your case. Slide them in. 9 cutouts, and we're going to put some silicones in each of them. This is an area where you can have a bit of customization as well. Depending on the number of these silicone mounts that you're using, the level of isolation from the case would change. And so if you're looking for a slightly softer typing experience, you would use less of these. It would also have an impact on the sound profile of the keyboard. Now that we've got our gaskets in place, our ribbon cable connectors are above the board, and so there's a little slot right here for you to feed that ribbon cable through. So This part, you got to be very careful. Ribbon cables are inherently relatively fragile. You want to make sure that you gently slide that through. Our gaskets are the part that's contacting the case and nothing else. And it gives us this nice springy action. The first part of it that is springing is actually the gaskets that are compressing, followed by the plate actually bending itself. And that's what gives you a very nice and soft typing experience. Next up, we connect our ribbon cable. In case we're using two separate ribbon cables, depending on your board, you might have less or you might just have pogo pins. The reason why we're having two ribbon cables here is that we've got one ribbon cable connecting the base of the case to the PCB. This is the base of the case ribbon cable, and it comes through and it connects to a PCB like so. Connecting my PCB to electronics on the case. And what do you think we have in the case? Well, we've got a couple things. Most importantly being my USB-C port is attached to the bottom of the case, as well as these little switches in the back over here is connected to this ribbon cable, and that carries the signals from the case electronics to the PCB. And that's how you're able to connect a USB-C cable to the case and not directly to the PCB. So now you're going to ask me, the second question is, well, what exactly is this second ribbon cable for? The reason why we have a second ribbon cable and why yours might not have one is that this ribbon cable essentially connects my PCB to the screens on top of the case. If your keyboard doesn't have screens on top of the case, chances are you will not have this PCB. This is the reason why this board has two separate ribbon cables. One important thing about ribbon cables to remember is when you subsequently disassemble this case, you can see the ribbon cables that's still attached. If you forget and you yank it off the top of the case, you will break either the ribbon cable or, worse still, the connectors below, and that's when you would have some severe damage. And so be careful when dealing with boards like this. Always remember that there's a ribbon cable attached. And if you may be asking, how do I know when a ribbon cable is fully attached? There's a little plastic latch. Up means it is unlocked, and that's when you can pull the ribbon cables out, right? You've got these connectors in the bottom of the ribbon cable, and what you essentially want to do is you want to feed this part in to this white part of the connector, and you will see that it slides in and it stops, right? So here, I'm sliding it in gently, and it's as far as it could go. And now I push this latch down, and that basically locks up my ribbon cable in place. Tricky part about this ribbon cable here, it actually exceeds the perimeter of the board, so I think we're going to actually have to squeeze it this way a little bit to make sure it doesn't get pinched. In my opinion, they should use a slightly shorter ribbon cable, so that might be a next iteration. Both of my ribbon cables are in, and we can screw it back on. And it's alive! Oh, that's so cute! Look at the little bear. For this build, we are going to be using 80 Retro's Day of the Dead polish keycaps. Very different type of visual here, but we're excited to see how it comes out. Let's get going. And we are done. Look at this beautiful board. That looks absolutely amazing.
Please like, subscribe, and comment below. Your feedback is invaluable to us and helps us make interesting content for you and better serve keyboard enthusiasts like yourself.